All right, so this is a IB non-calculated question regarding volumes of rotation. So we're going to take a region and rotate it around the x-axis. It says the region enclosed between the curves y equals square root of x e to the x and y equals e square root of x is rotated through 2 pi about the x-axis. Find the volume of the solid obtained. Okay, so essentially what you've got is you've got your two lines. No, I don't know exactly what they look like. No, I really don't care. Two lines that cross, and you create some type of region, which then is going to be rotated around the x-axis. Okay, just like this. Okay, and create some type of shape. Okay, it looks like, and since we don't know what they look like, we can't really determine what the shape looks like, but we do have two volumes there that are being rotated around. So what we need to do is we need to find out first where those intersections occur so we know which region we're looking at. So to find that, we're just going to find the intersections. So we're going to set up the square root of x e to the x equals e square root of x, and I think the easiest way to solve that is to subtract the e square root of x. So we've got the square root of x e to the x minus e square root of x equals 0, and then we'll factor out the square root of x. So you've got square root of x times e to the x minus e equals 0, and at that point you can set each piece equal to 0. Square root of x equals 0, square both sides, and you get x equals 0. So there's one intersect, and then I've got e to the x minus e equals 0. And you can solve that any number of ways. One way would be to add the e to both sides, so e to the x equals e, and of course that's e to the first, which means that x equals 1. So I've got my two intersections for those two lines. And so now what I want to do is I want to find the volume of each of those pieces as they're rotated around. And the nice thing is, because there's only two volumes, I can just take the bigger volume and then I'll subtract off the smaller volume. Because just looking at it, I may or may not know right off the bat which one of these is the larger y value. There's several ways you can test that. You can test a number between 0 and 1. That might be a little difficult without your calculator. You can test a number like 100, right? If you put in a number like 100, this number right here is going to be e to the 100 power. I can guarantee you that's going to be significantly larger than this one. So because e square root of x e to the x is bigger out here at 100, that means that they've crossed. So between 0 and 1, this is probably going to be the bigger one. But let's go forth as if we didn't know that. Okay, so we're just going to take the first one. So we'll take volume 1, which is this equation right here. So of course to get that, we do pi integral from 0 to 1, because that was my intersections, and we're going to rotate it around, which means we're just going to do the square root of x e to the x squared dx, and so from there we should be able to work it out. So we got pi integral from 0 to 1, and then we go square root of x squared would be x, and then you have e to the 2x dx. Now, hopefully you'll notice that we've got a product here. You've got x times e to the 2x. There's a number of different things you could do here. Let's, for the sake of doing it, let's do integration by parts. Okay, so we've got u, we've got v. All right. So I'm going to make u the x, because that's the one that I'm going to take the derivative of. That'll simplify it a little bit later. And then I'll have u prime, which of course is just going to be equal to 1. And then I've got v prime, which is the other one, because this has to be u v prime, right? So v prime is going to be e to the 2x. So v is the integral of that, which is just e to the 2x. But because you've got a linear in the argument there, that's just going to be 1/2, because it's 1 over a. So then I've got my u prime, v prime, and so I can just write it out so that v1 is equal to uv, so x times 1/2 e to the 2x, so 1/2 x e to the 2x, minus the integral from 0 to 1 of v du. So v is, of course, still your 1/2 e to the 2x, and then du would be 1, and so 1 dx, and so we're left with that, which then can be finished off because we can take that integral. So, and of course this, I guess this should still be evaluated from 0 to 1. All right, so that we can go ahead and work out. If I put 1's in, then it's going to be 1/2 times 1 times e squared minus, and if I put 0 in, it's just all going to be 0, so I don't really have to worry about that. Minus, and then take the integral of this, so it's still going to be e to the 2x, and again, because of the argument, I'm going to need a 1/2 in front, so half times half would be 1/4, and again, still evaluated from 0 to 1. I'm not going to worry about the c because it's a definite integral, so the c's are going to end up canceling out. And so, again, when I put in these numbers, the volume 1 will be 1/2 e squared, and then if I put in 1, so it'll be minus 1/4 e squared, because when I put the 1 in, it'll just be e squared. And then when I put the 0 in, it'll be, this should be minus the 0, so minus a negative will be plus. So 1/4 e to the 0, which is 1, so plus 1/4. All right, so at that point, we're done with volume 1, and so we'll go on to the second one. This one will be significantly easier. I'll go ahead and do this one in a different color just for our reference. So I'll do volume 2 over here. So volume 2 is ex, so it's going to be pi integral from 0 to 1 of e squared of x, again, squared. Okay, now this is the part where people often get tied up a little bit, because a lot of people look at this and they say, oh, well, I'm going to have to do integration by parts again. But the key here is to recognize that e squared is a constant. Okay, so this is just like having the integral of 2x, except it's not 2, it's e squared. E is just a number. It's not a variable, it's not a parameter, it's a number, just like everything else. So in that case, what we're going to do is we're just going to take the integral. Oh, sorry. So we've got pi, and I think I lost my pi in here somewhere. Sorry, I'm just going to put pi in there. So we still got pi in there. All right, so what we're going to do is we're going to go ahead and take the integral, which will just be e squared, and the integral of x is x squared, and then we put the 1/2 in front. And again, we're going to ignore the plus c, and so we'll go from 0 to 1. Note that when I put 0 in, it's just going to be 0. So when I put 1 in, I'm going to have pi e squared times 1/2. And so when I put all of that together, right, we already said earlier that this was the larger one. So it's going to be v2 minus v1. So it's going to be v2. So if I simplify that, it'll just be pi e squared over 2. And then subtract. Again, we've got pi e squared over 2. We've got minus pi over 4 e squared, and then plus pi over 4. And so when we do that, these two right here will cancel out, the pi e squared over 2 and the minus pi e squared over 2. And so we're left with negative times negative, so pi over 4 e squared and minus pi over 4. And you'll see we can take out the pi over 4, and so our final answer is pi over 4 times e squared minus 1. And that is our answer.